Now let's take a look at the three parts of the migration phase: migrating the workload, testing the workload, and making the new workload live. PlateSpin Migrate allows you to move your server workload without having to take it offline. This is an important feature when migrating business-critical workloads that you can't afford to take down. The testing process ensures the new workload will run as predicted in the new environment. Once testing is complete and you're ready to go live with your new virtual workload, PlateSpin Migrate lets you sync any changes that have occurred to the workload to ensure it's up to date. Let's take a look at how PlateSpin Migrate works.
PlateSpin Migrate is a workload migration solution that allows you to move server workloads over the network between physical servers, virtual hosts, and image archives. Migrate decouples the underlying server hardware and transfers workloads to and from any physical or virtual host. PlateSpin Migrate provides organizations with a mature, proven solution for testing, migrating, and rebalancing workloads across infrastructure boundaries from desktop to servers. Once Migrate is installed, the first thing you see is the server's view. The console consists of two split panes and lists of discovered sources and targets. Before you can begin, you have to discover a source and a target. These can be either a physical or a virtual machine. The back-end architecture consists of a Microsoft SQL Express database. WMI is used to communicate with Windows servers, and SSH is used to communicate with Linux and ESX servers. To discover a server, a hostname or IP address is required. Once the source and target have been discovered, you can select any of the following functions: copy workload, move, capture image, deploy image, and so on. Now I'll walk you through the process of a physical to virtual server move. We'll just click Move Workload here, and the wizard pops up. This wizard will guide you through the process of migrating or converting a physical server to a virtual machine. For this demo, I'll take the physical server NYSQL 2005 and walk you through the P2V process. We'll pick this ESX server over here as the target. Once we've picked the source and the target, we just click Start Wizard. As part of the P2V process, we can make changes to the workload. But before we can even begin, we need to have the right credentials. So for Windows servers, we need a minimum equivalent of a local or domain admin account. For Linux and ESX server, we need a root or sudo account. Now let's look at transfer methods. Take control is a cold migration process. This involves shutting down the source machine in order to migrate the workload. This is usually used for Linux and legacy Windows NT servers. In some cases, this process can also be used to migrate Windows 2000 and 2003 servers. The live migrations process is supported for Windows 2000 server and above. The process copies data from the source to the target without production interruption to the source machine. The live migration process consists of three different options. The first option is your typical file transfer. The file option is typically used for low transactional servers like web server and file servers. This option is not recommended for database servers or highly transactional servers. The block-based transfer option can be used for database servers and highly transactional servers. Migrate captures and stores the block layout of the drives and then streams the data block by block across the LAN or WAN without having to stop any services. The blocks are then reassembled. The data blocks and the blank blocks are then transferred and rebuilt to match the same disk geometry. The snapshot option utilizes VSS technology that is only available in Windows 2003. This is a file-based transfer option. The difference is we can take advantage of Volume Shadow Copy service. This service allows Migrate to copy SQL database and Exchange databases without having to stop services. The hostname option is used mainly on the provisioning side for the purpose of cloning a server. You can change the name of the server, join a domain, and generate a new SID if necessary. Networking allows you to keep the existing network configurations such as the IP address, DNS, and WIN settings. Virtual machine configuration allows you to pre-configure the virtual machine name and CPU and memory settings for the target virtual machine. In volumes, you can select which drives will be part of the move. You can also increase and decrease the drive sizes before migrating the data. On this page, you can choose to stop, start, or disable Windows services. When migrating from a physical server to a virtual server, some hardware manufacturers' services that depend on specific hardware may cause the server to blue screen. So here you have the option to disable them. Now let's look at the advanced options. The advanced options allow for a more granular job configuration. The schedule option allows you to prepare migrations in advance, so migrations do not have to be run immediately. I can set up a job and then have it run at a later time. During the migration, you can receive an email with an up-to-date progress report on the migration job. When notification is turned on, the process will also alert you when a failure occurs and on completion. At this point, you have built a P2V job using PlateSpin Migrate. The only thing left to do is click Start and run the job. That concludes this brief introduction demo. You now have an idea of how PlateSpin Migrate can reduce the risks associated with workload relocation projects like server consolidation and data center relocation.